Hi, welcome to our presentation regarding 5G XL transport solutions. My name is Raza Kahn, and I'm the Senior Market Manager for Wireless Products in Semtech's Signal Integrity Products business unit. A little quick overview about Semtech. Semtech is a global company, publicly traded and headquartered in Camarillo, California. Our three main business units include Signal Integrity Products Group, the Protection Products Group, and the Wireless and Sensing Products Group. Today, we will be talking about the 5G wireless market from the Signal Integrity Products Group point of view. As Semtech is a leading supplier of high-performance analog and mixed-signal semiconductors for infrastructure, high-end consumer, and industrial equipment markets, our signal integrity technology really enables the transport needs in wireless, front haul, mid haul, and back haul, data centers, and PON applications. Semtech's wireless chipsets offer low cost, very low latency, and low power for the demanding 5G wireless, 4G wireless, and legacy systems. We are very lucky to be involved in the wireless space for a very long time. And a majority of the 4G deployments today use our wireless platforms. And we're already innovating for the next generation of 5G deployment, including the first to market sampling of our Tri-Edge PAM4 technology to enable the next generation of millimeter wave and C-band deployments, enabling twice the packet bandwidth. Before we start to look at what offerings are needed in a particular market, it's critical to understand the fundamental growth factors within that market segment. Looking at a recent report by Ericsson about mobile subscribers, as well as the global mobile network data traffic, it's clear that the traffic demand is expected to grow at an explosive rate. Mobile subscribers for 5G are expected to be around 3.5 billion in 2026, up from 580 million by end of 2021. And at the same time, the per user data traffic is expected to triple or quadruple. What that means is all that front demand needs a highly capable system and infrastructure to enable the end user throughput, particularly putting importance in front haul 5G deployments. And that's where we'll focus today. So what this demand brings us to is the next stage of the different choice of architectures. This diagram over here from Nokia shows that 5G RAN or radio access network gives a lot of options or choice to the service providers and system vendors, rather than just adopting a single architecture as what was done in the 4G wireless days. What that means is that there's a few key technology trends that occur due to the 5G deployment. The adoption of massive MIMOs, the EC3 protocol adoption, the introduction of Cloud RAN, as the base stations or the baseband units are split between a distributed unit and a centralized unit. It allows the service providers and system vendors to offer Cloud RAN options such as edge cloud or centralized locations. It also means that once the macro base station deployments are stable, small cells will really start to be deployed in a very massive way in order to provide the same level of coverage inside every building, inside a community, and inside the high capacity cities. And then the aggregation of all these cell sites, radio sites, and the distributed units really increase the capacity requirements for the front haul and the mid haul networks. And all that is really chosen, the architectures are chosen based on a trade-off for cost, performance, and the services offered for the 5G wireless consumer base. So all this extra capacity leads to certain challenges, and every challenge is really an opportunity for the industry to innovate. Some of the challenges include the front haul and aggregation requires upwards of 25, 50, and 100 gigabits and beyond optical line rates to really allow the use of the massive MIMOs and the higher spectrum and RF bandwidths. But at the same time, minimal latency is key to enabling the time-sensitive networking, TSN, or precision time protocol requirements, particularly in the front haul and the mid-haul layers. So this is some of the areas where Semtech is also trying to work with our partners to really innovate. So how does Semtech fit in all of that? This is a simplified version of a 5G radio access network. And as you can see, Semtech enables the optical links and offers IC solutions for the optical modules that connect the different equipments, the massive MIMOs, the baseband units, or the aggregation equipment together. And our products generally include ICs that are integrated with clock and data recovery devices, TIAs or transimpedance amplifiers, and laser drivers. This slide just tries to give you an overview of the vast portfolio for Semtech's wireless products, including our 10 gig fiber edge products and our 25 gig clear edge products that are already shipping in production and volume. And we're also very excited to announce the sampling for our 50 gig tri-edge PAM4 platform to all tier 1 customers, which really differentiates on this latency requirement, enabling less than 0.5 nanoseconds of latency, while also enabling ultra low power and low cost optics using our proprietary tri-edge technology. So in summary, in our opinion, the high front haul bandwidths at ultra low latency, low power, and low cost are really the solution needed to support new 5 gig deployments and architectures. We're very lucky to be involved in this space for a long time and are proud that our offerings are being utilized by our customers for both 10 gig fiber edge and our 25 gig clear edge platforms. We're very excited to be working with our partners and our customers to enable the next round of phase 2 5G deployments with our tri-edge 50 gig platform. And we'll continue to work closely with the industry partners to really offer innovative and differentiated solutions for all of our core markets, including wireless, data centers, and PON. That's all for my presentation. I'd like to thank everyone for their time and really do appreciate the opportunity to present today. Thank you again.